Now let us see how this can be projected in third angle. We had seen the projection of this particular object in first angle. Now what is third angle and how this object would be projected? So third angle means these are the four quadrants. This was the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So when the object is kept in the third quadrant, the rule is the viewer has to view the object from in front of the principal vertical plane. So viewer is here, object is here. That means the projection plane is transparent. Projection plane is transparent and one can view the object through this transparent plane, and whatever is visible that would be drawn on this projection plane. So here if you see how the things or the relative positions of plan, elevation and side view would change, let us take again the same box example to explain the things. This is the same box which I did use to explain third angle method of projection. Now the object is kept inside. This is the principal vertical plane for projection of elevation 1, 2, 3, 4. The terminology, that is elevation, plan, side view, they don't change, but their relative positions they change. Hence, suppose this is the object, viewer is viewing the object from outside this box. So projection plane, earlier it was 1, 2, 3, 4, but in the present case, as is clear from here, viewer is here, object is there, and the projection plane is here. That means now the projection plane would be 1 dash, 2 dash, 3 dash and the 4 dash. So this won't be the projection plane any longer, and this is a transparent sheet, so the viewer can view the object. So I am just rubbing all these previous numbers previously drawn. So now our projection plane is this. Then so viewer will view the object and on this surface elevation would be projected. Now to have the second important view, that is plan, viewer has to move at the top, and now the projection plane is 3 dash, 4 dash, 5 dash and 6 dash. Now again you see the condition, relative positions of plane, object and viewer are same. Object is inside this is the projection plane is 3 dash, 4 dash, 5 dash, 6 dash, and this is the viewer. So the view would be coming over here, and now to bring all them in one plane, we will rotate this plane in the plane of elevation, keeping it fixed. So this is the new position of the plan. This is the new position of the plan, which is at the top of the elevation. Mark the difference. In first angle, the plan was below the elevation, whereas in this particular case, in third angle, the plan is above the elevation. Then top view is at the top of elevation. Here in case of first angle, top view was at the bottom of the elevation. Now this is the elevation and this is the plan. Now if we go for, I will take the same view, that is left hand side view. So for left hand side view, viewer will again come to its place and it will come over here to view the object from this side, from left hand side. Now the projection plane would be 1, 4 dash, 5 dash and 7 dash. So the projection plane for left hand side view is the plane which is left to the elevation plane, and if we turn it in the plane of, if we turn this in the plane of elevation, so this would be the left hand side view which is to the left of the elevation. So the view RHS or left hand side view or right hand side view, they would be to the respective sides of the elevation in case of third angle method of projection. Now let us see how this object would be projected and how the relative positions will be there. Mind it, now the plan will be coming at the top of elevation, hence I am starting the elevation at the this quadrant. I am starting it from the third quadrant. Here I had started with the, this is not the quadrant, this is basically the plane intersections. This is principal horizontal plane, this is the principal vertical plane, and this is the intersection. So these are the plane intersection lines. So elevation I would be drawing over here, plan over here, and left hand side view would come to this side. This planning is necessary in case of third angle method of projection. Again I take the rectangle because I know total width and total height of this, and hence I have all the dimensions with me. So this is the rectangle in which the elevation would be limited to. So again, for elevation, this is the first surface, this is the second surface, this is the third surface, this is the fourth surface, and this is the fifth surface, which is marked over here. I am eliminating, I am rubbing all these for the plan. So now for elevation in third angle, the visible surfaces are number 1, number 2, number 3, number 4, and number 5. So in the similar way we would be projecting, so there won't be any difference in elevation for third angle or first angle. So I would be drawing it in the same manner. You can check. So this would be the projection of, this is surface projection of surface number 1, surface number 2, surface number 3, surface number 4, surface number 5. So for projection of this surface, I had started from this point. This is the starting point. So this line is parallel to the projection plane. I have to move up by this distance, which is 15 shown over here. Then I have to, this line is inclined to this, but its projection would be this 30 distance. So this 30 distance, 15, 30, and then again this line is parallel to the projection plane. This is inclined to the projection plane. If I am viewing the object from this side only, which I had selected for first angle method of projection also. So one surface, the projection of numbers, these two lines of this surface are parallel to the projection planes, so they would be in true lengths. These two lines are inclined to the projection plane, and hence they would be projected there foreshortened. This is the projection plane which is parallel to this plane, so plane number 2 or 4. This is projection plane is parallel to this. I tried to show it over here at the back of this. I am viewing the object from this. So now in first angle it was at the back, in third angle it is at the front of this. So I tried to draw this projection plane, and viewer is here who is viewing there. So this surface would be visible to the viewer like this. The second surface would be visible to the viewer like this, and so on. So this is the projection of, this is the elevation of this. This is the elevation. Then let us come to the side view. Now what will happen to the left hand side view? Left hand side, this left hand side view, this would be the, because it is at the right, so this would be right hand side view. I am trying a right hand side view for this object over here. So all the horizontal lines I am projecting for the purpose I did mention in my previous lecture for the, so this is the projection of all the horizontal lines for the right hand side view. So I am taking right hand side view. So viewer will move to this side to view the object. Now how it would be visible? Let me draw the rectangle or the boundaries of this. These are the boundaries. Then there are only two surfaces visible. One is this triangular one which I had shown over here from this side, and another one is complete rectangle minus this elimination of this surface. So that would be like this. Now the question is the dashed lines which would be visible. So in this diagram, this is visible as the dashed line, whereas here this is visible as the firm line, because I am viewing the object from the right hand side and the view is to the right of the. So now I have to start from here, and this line, if I view it from this side, I have to complete the depth of this and then come down by 24. So I have to start it from this side. So this, I'm sorry, this was wrongly done. Why? Because see, if we open this, now this left hand for right hand side view, the projection plane would be to this side, and when we will open this, this particular length would be away from the plane intersection line which I had marked over here, which is wrong. This particular side would be coming to this side, and hence I am correcting it. So the diagram would be, this would be, I'll explain it once again. When we open this, because this is the plane of elevation in front of it, second plane is over here, and that would be opened like this. So this surface, this particular length would be moving away from this is the plane intersection line, this would be moving away from this, and hence this would be to this side, and hence this is the starting point, this is the terminating point. So I had drawn over here, this is the starting point, this is the terminating point. So this would be visible like this. What other things would be visible over here? Other things would be visible would be, because this is 15, this is 30, so this line would be visible. This line would be for the dashed line. There are three dashed lines which I have to draw. One is this one, second one is this one, and because this distance is 15 and this is 30, 36, hence this would be visible. So this line I can mark, because this horizontal line I have already taken, so I have to extend it, and the projection of this line, in fact this line would be visible, hence this is completing the whole depth. So I know the height of this, and this would be the projection of this dashed line. So dashed line number, if I mark it over A, so A would be projected like this. Then these two dashed lines, since these are from this side, so this corner where from these two lines are starting, that would be towards the plane intersection line. So that is this corner. This corner is this corner. I have to start it from here. So for this line, I have to move down by the whole height of this and then move inside 30. So I have to move down from here, I have to move down and inside 30, I have to move down and inside 30. So this would be the starting point, this would be the terminating point, and the projection would be like this. Then this line, for here I have to complete the whole width and then come down by 24. I have to complete the whole width and come down by 24. So this would be the starting point, this would be the terminating point, and the projection would be like this. So this is the complete projection of this object, that is right hand side view. Mark the difference over here, how they are different. All the three lines are dashed lines, whereas this is the. Now comes the plan. Plan would be at the top of it.